I'm on page 77 in the exercise book, and we're looking at number 15. I like these problems because these are real-world applications of this skill, and I use this skill a lot in my everyday life. Number 15. Consider the following graph and equation which describe the cost y of hiring two different painters for X hours. So the independent variable is X. That's what I have a choice about. The dependent variable is the cost. So depending on how many hours I choose, the cost is going to change. So painter A, I'm given a graph. Painter B, I'm given an equation. And I need to standardize these. I need to see two graphs or two equations. And I would rather see two equations. So I'm going to focus right here and write an equation for this graph. So here's the question. If I know the answer to this question, the equation will be very simple to write. What is the rate for 1 hour? That's the unit rate. And remember, that's also the slope. But in this situation, I want to know the rate for 1 hour. And I can tell you that just by looking here. If I go over 1 hour and I go up to that dot, that point, I know the rate. So it's going to be $25 for 1 hour. That's rise over run. You rise 25, you run 1. So $25 for 1 hour. The equation for this one is 25 times the number of hours you want to do. So this is saying the cost is $25 times the number of hours you're looking at. This is saying the same thing. And because these are saying the same thing, I can compare right here. Now, the other thing we need to consider is where this graph touches the y-axis, and that is at 0. So adding that in doesn't change anything. We're still left with $25 per hour. This would represent a flat fee. So, for example, if I call painter A and they charged me $100 to come and give an estimate, that would be that flat fee. But neither company does that. So they're both just an hourly rate. So which statement is true? Painter A is more expensive than painter B. That is not true. Painter A is $10 cheaper than painter B. Painter B is less expensive for the first hour. That's not true because each of them charge a flat hourly rate. Painter B has the same initial fee as painter A. That's true. This is kind of tricky because neither of them have an initial fee. So they are the same. Both of them are 0, but neither of them charge an initial fee. So that's a little tricky, I think. Painter A charges $5 less per hour than painter B. That's not true. They charge $10 less an hour. So that would not be true. And painter B charges 1 flat fee. No, painter B charges an hourly fee. So this is C. Number 16. Consider the following equation and table which describe the distance in miles y traveled by 2 rowers who each rowed at a constant speed for X hours. So a graph of this scenario would look like this, where you have, gosh, that's too big. You have on the y-axis, you have miles. That's the best I can do, guys. I'm sorry. You have miles as your dependent variable. So the miles traveled will depend on the hours rowed. So X is hours, Y is miles. Okay, the first rower covers 10 miles per hour. In rower B, if we look right here, we can tell the unit rate for this one. So what we're trying to do is determine a unit rate. For this person, for A, the unit rate is 10 to 1. For this person, the unit rate is 15 to 1. So who is rowing faster? This person is doing 15 miles an hour, and this person is doing 10 miles per hour. So rower B is rowing faster. After 2.5 hours, which rower traveled farther? Well, I can tell you it's rower B because he's going faster to start with, but they also want to know how many miles. So we're going to have to do some math here. All right, rower A is y equals 10x. So that's going to be y equals 10 times 2.5. So at 2.5 hours, this person has gone 25 miles. Rower B is y equals 15 miles an hour. So y equals 15 times 2.5. And I believe that's going to be 40, but I'm not going to take the chance. 15 times 2.5. That's why I don't take the chance. 37.5 miles. Now, farther with an ER on it means something. It means subtract. So we will say 37.5 minus 25 is 12.5 miles. So I will say that rower B is traveling faster and farther, and in that time specified, will travel 12.5 miles farther. To me, that question is a good question. It's practical. It's something that actually makes sense. We're not just calculating slope over and over. We're calculating an actual story. Okay, number 17. Consider the following table where we have time in minutes. That's the independent variable. So if you sketch this graph, you're going to have time in minutes. And depending on how many minutes you type, you will have some words texted. Okay, so we need to know the unit rate. Now you can find that. You can make it a lot harder than it is, or you can find it pretty easily right here. We have 150 words, not per minute. That's for 3 minutes. So if we break this down to 1 minute, remember words is on the y-axis, rise over run. How many words in 1 minute? Divide top and bottom by 3 and you'll get 50 words per minute. So the unit rate for this one is B. 1 minute, 50 words. When I was in school, it was how many you could type. Now it's how many you can text. Okay, number 18. Consider the following graph. Okay, the question that I'm always going to ask myself is what? Let me back up. If I see this, 0, 0, that's proportionality. If I'm looking at proportionality, I always want to know what is the rate for 1. And in this case, it's items. In the last example, I think it was hours. What is the case for 1 item? So, when I go over to 1, what is the rise? Right there. So at this point, when X is 1, that's 1 item, Y is 3. So the answer, and Y is cost in dollars, so for 1 item, it's $3. That's called the unit rate. That's also our slope. You rise 3, you run 1. So $3 for 1 item. And I like answer D on this one. $3, 1 item.